All right, so we will move now on to the last part of the lesson, non-uniform bodies. Okay, so how do we find the center of mass of non-uniform bodies? Basically, non-uniform means you find, the body is made of of materials of different density. So that's what they mean by non-uniform. Okay, so let's see how it's done. It's actually really easy. Okay, since now you know the basic principles of the lesson, it's really easy. Okay, look, a uniform. So this is from exercise 5C, question number 1. A uniform solid right circular cone of height 10 centimeter and base radius 5 centimeter is joined at its base to the base of a uniform solid hemisphere. The centers of their bases coincide and their axes are collinear. The radius of the hemisphere is also 5 centimeter. The density of the hemisphere is twice the density of the cone. Can you see, guys? So this is where the non-uniform comes into play. Can you see the density of the hemisphere is twice the density of the cone? So that is the place where this non-uniform bodies come into play. Okay, so it's really easy. The question is find the position of the center of mass of the composite body. All right. So you can first thing is you draw the diagram. So you can see we have a right circular cone, height 10 centimeter, base radius 5. Can you see my diagram? Okay, and it's joined at its base by a uniform solid hemisphere. So at the base, you join a hemisphere, and you can see since the hemisphere also has a radius of 5 centimeters, these two objects they coincide, right? So they fit exactly. So that's why it's a perfect fit here. But you can see the cone now they say very clearly the density of the hemisphere is twice as whatever it is in the density of the cone. So density of the cone, if it is rho, so guys, the only difference here is the density of the hemisphere is gonna be 2 rho. Can you see density of the hemisphere is gonna be 2 rho? So that's it. And from this point onwards, the rest of things are exactly gonna be the same. What are you gonna do? You're gonna write object, mass, center of mass, right? And and you need to decide from where you're gonna measure your center of mass. Like what's your 0, 0? That needs to be very clearly decided. So I will decide to take 0, 0 from the very bottom. I'll choose this as x. Okay, the bottom. So if you want, you can take it at O. Wait, let's see. Find the position of the center of mass of the composite body. Okay, so we need to decide. Okay, which one is the best? Whatever is easier. Which point do you want to consider the center of mass? All right, guys. So choosing the center of mass, either you can go with O or you can go with the point X. Entirely up to you. Okay, so if you go with point X, all the center, everything is above X. So all your distances are gonna be positive. Okay, but if you choose the center of mass, sorry, not center of mass. If you choose your 0, 0 to be at O, the cone is above, so that distance is positive and the hemisphere is below, so that distance is going to be negative. Okay, so it's entirely up to you the way you choose. So I think I've been doing everything positive in all the questions I've done in the in this particular lesson, right? So let me do one where we have positive and negative distances. Okay, so I'm going to consider O as my 0, 0. Okay, fine. Then when it comes to the mass, okay, so mass is proportional to the volume, and you also have to multiply by the density to make it, the volume you multiply by the density to get the mass. So mass of a cone, so volume of a cone 1 over 3 pi r square h into rho, right? The mass of the cone, density is rho. So let's input the values 1 over 3 pi r square. So that's 5 square. Radius is 5. H is 10 into rho. Right, guys? That's going to be 25 into 10, 250 over 3, right? 250 over 3 pi rho. Grid, guys? Okay, so that's done. And then center of mass. So now you need to remember these equations, right, guys? So these were all proved in the previous sections that we were discussing. So center of mass of a solid cone from its, not from the vertex, but from the base. Okay, so can I know how much that is? Yeah, so the center of mass, guys, it's in the formula book as well. We have done this previously. So it was 3 over 4h from the vertex or 1 over 4h from the circular base. Do you remember? Right, so let me say this is G1. So G1 is the center of mass of the cone. So it's at a distance 1 over 4h. Okay, so I'm directly measuring from O and it's above O, so it's positive, right? So 1 over 4h. I don't need to add any extra component. So 1 over 4, H is 10. So that's going to be 5 over 2, right, guys? Okay, and now let's go for the hemisphere. So the mass of the hemisphere, that's basically volume. So volume of a sphere is 4 over 3 pi r cubed. So hemisphere, half of 4 over 3 pi r cube, right? Pi r cube radius is 5, right, guys? 5, right? R cube is 5 cube. Okay, half of 4 over 3 uh, pi r cube into, guys, what about the mass per unit volume, the density? Now, very clearly, I have marked here also, density is not rho now, it's 2 rho. Can you see? Because with the hemisphere, the density was double the density of the cone. So this should be 2 rho here. That's the important thing. Can you see, guys? That's the main difference. Okay, the earlier one was rho, this is 2 rho. Okay. So now let's get the mass. So it's gonna be half cancels, simplify. 5 cube, that's yeah, 125 into 4. How much is that? 500 over 3 pi rho, right, guys? Okay, and then the center of mass. Okay, now be careful here. The center of mass, yeah, remember you are measuring from O. O is your 0, 0. And so this is, let's say, G2. Okay, G2 means the center of mass of the hemisphere. Okay, so it's at a distance of, so if you again check your formula book, center of mass of a this is a solid hemisphere. Center of mass of a solid hemisphere is at a distance 3r over 8. Right, guys? It's at a distance 3r over 8. So you can turn your books and check the theory. We have even done the proof, right? So it's at a distance 3r over 8 from the circular face. Agreed? So, by the way, now the thing here is this distance 3r over 8 is actually what? It's below, right? It's below the point O, not above. It's below. So, therefore, your center of mass distance is, guys, it's negative. Okay, but since it's below. Okay, I chose O as the origin. Okay, 0, 0. O is my origin. Okay, so that's why I'm going to use a negative now. So this is because I did every other question in the lesson by using always the base position. Okay, so now in this case, I want to do a slight difference. Okay, just to show you the other options available to you as well. Okay, so considering from O. So it's going to be 3r over 8, but guys, it's going to be negative 3r over 8 because it is below the point. Okay, right. So then input the value, radius is 5. So minus 3 times 5, that's minus 15 over 8. Right, guys? Okay, so finally, the final mass, I mean, combining the objects together, you need to add the masses, right? 250 over 3 pi rho plus 500 over 3 pi rho. That's going to be 750 over 3 pi rho. And the center of mass is going to be, let's put it as y bar. Okay, guys. Okay, so center of mass is y bar. Remember, we are measuring the center of mass from the point O. Okay, I'm using here point O. So remember, if your y bar is a positive answer, it means your center of mass is lying above O. But in an event, if your center of mass is a negative answer, if you get y bar as negative, don't panic. Okay, it means your center of mass is below O. Okay, so you don't need to worry. And x bar, we don't need to find the x bar, right, guys? Very clearly, you can see you have one axis of symmetry. If there's one axis of symmetry, one coordinate of your center of mass is automatically there. Right, guys? So over here, we don't need to find x bar. X bar is automatically 0 because it's on the y-axis. I'm considering this. Okay, guys? Right. So now we are ready with everything. We have all the information we need. Let's multiply. Okay, so sigma mi yi equal total mass into y bar. So sigma mi 250 over 3 pi rho into 5 over 2 plus, okay, we're adding, right, guys? We're adding the two objects, we're adding. So plus 500 over 3 pi rho into, guys, be careful here, it's minus 15 over 8, right? It's minus 15 over 8. Equals total mass is 750 over 3 pi rho into y bar. Agreed? Everyone has pi rho. Cancel out the pi rho. And then multiply and get the answer, guys. All right, guys. So you typed it in the cal. So this part plus this one, of course, it's a negative sign here, which means automatically the minus comes over here. So it's a negative term end of the day, right? So you get this answer, and then you divide that by 750 over 3, or you multiply by 3 over 750, right? Same thing. And then you get y bar. Guys, over here, look what it means. Okay, so your y bar answer is minus 5 over 12. So minus 5 over 12 means what? What does it mean that your y bar is negative 5 over 12? Guys, remember you measured everything from the point O, and I told you above O is positive, below O is negative. So clearly what it means is the center of mass of the composite body is at a distance 5 over 12 centimeters below O. Right, guys? So that's what it means. So center of mass of composite body is at a distance 5 over 12 centimeters below O, not behind, sorry, below. All right, guys. So this is what it means. It means your center of mass definitely will never exceed 3R over 8, right? You need to really definitely understand that your center of mass probably comes somewhere like over here. Can you guys see? The main G comes probably somewhere in between. Okay, because always center of mass comes between G1 and G2. Okay, so below O, it should be like somewhere probably over here. Okay, so it's just the distance. Okay, and the negative mark is just giving you an indication of the direction here, because over here we have two directions to go to from O. Okay, so if you so because we considered O and we got a negative, it means your combined object has center of mass below the pointer. Okay, so you can give this as your answer. Center of mass of composite body is at distance 5 over 12 centimeters below O. So that's what they need to see. All right. Okay, guys. Okay, guys. So let's move on to question number 6. So they say a solid wooden ball is modeled as a uniform solid right circular cylinder with height 2r and radius 4r. Okay, the center of one face is at O. A hemisphere of diameter 2r is removed from the ball. Okay, the center of the hemisphere lies on the diameter of the circular face of the cylinder. The center of the hemisphere, okay, so the center of the hemisphere, can you see the center of the hemisphere is the point P, right? You guys are following me, right? The center of the hemisphere, okay, the center of the hemisphere, that's the point P, okay, lies on the diameter of the circular face of the cylinder. Can you see? So it's on the diameter. So basically, it's on the diameter. Okay, point P is like on the diameter of the cylinder. And the point O lies on the circumference of the circular face of the hemisphere. Point O. Point O is exactly the top middle face, right? Of the circular face of the hemisphere. Circular face, yeah. Point O is on circumference of the circular face of the hemisphere. Okay. Show that the center of mass of the whole ball is at a vertical distance of 381 R over 376 from the plane face containing O. Okay, guys. So here's 6 marks, right? So it's a 6 mark question. They're asking you to find the ball in the sense that they are saying here, right? A solid wooden ball is modeled as a uniform solid right circular cylinder, and you are removing a hemisphere, right? So this is the ball, right? From this solid right circular cylinder, you are removing the hemisphere, and then they are saying that is what is considered as the ball here. All right, guys. So, what do we need to do here? You're supposed to get the show that, and the show that is they are asking you the distance of the center of mass from the point O. Can you see? Show that the center of mass of the whole ball is at a vertical distance. Now, the thing here is this. Okay, now there are several things to understand. In this question, you don't have different densities. Okay, densities of both objects, the cylinder and the hemisphere, are the same. Okay, but the thing that's different here is, guys, all this time, if you saw, we were working with symmetric objects, right? We always had an axis of symmetry. So the previous question also we had an axis of symmetry, but over here in this question, can you see that there is no line of symmetry for both the objects together? Because the thing is, you have removed the hemisphere, like not centered around O. So it's removed somewhere else. So because of that, it's not symmetric. So in this case, in your center of mass, you not only have to find the y bar, but you also have to find x bar if you are considering center of mass. Okay, guys. So that's the main difference here. That's why the non-uniform comes into play here. Okay, just because you don't have an axis of symmetry and you can't just escape by find. I mean, if you want the center of mass coordinates, you'll have to find both x bar and y bar. All right, guys. Okay, but over here, I mean, part A, they are asking the vertical distance. So if they are asking you the vertical distance, in other words, they want you to find the y bar distance. Okay, guys, they want you to find y bar. Now, remember here, x bar is not zero. You can't consider that the center of mass is on this OX line. Definitely not right, guys, because this is removed from over here. Your center of mass is not going to be on the OX line. It's not. Okay. So your x bar is not zero. If you want to find x bar, you'll have to find do workings and find x bar. Okay. So anyway, in part A, you're supposed to find only y bar. Okay. Right. So let's do that. So finding y bar. So you can see here object. So we have done the working. So object mass and center of mass. So this is the one that we are removing, right, guys? So this is the one. This is the hemisphere that you are removing. So it's half of 4 over 3 pi r cube into rho is the density. Okay. So radius. Have they given us the radius? They have given the radius is a hemisphere of diameter 2r, right? So if the diameter is 2r, then radius is r. Are you with me, guys? If the diameter is 2r, then the radius is r. Okay, so over here, half of 4 over 3 pi r cube rho. Okay, so our radius is r directly. Okay, so half and 4 cancel, so you get 2 over 3 pi r cube. I hope you guys can see this. Okay, so it's 2 over 3 pi r cube rho. Center of mass of the ball is at a distance 3 over 8 r from the point P. So from this point P, the center of mass is at a, so this is G1, it's at a distance 3 over 8 r. Okay, guys, so that's 3 over 8 r. Directly the vertical distance. So we have considered directly the vertical distance. Okay, from point O. So we will consider center of mass from point O. Okay, so from point O, it's at a vertical distance of 3 over 8 r because point O is over here. Okay, but still the vertical distance doesn't change. It's still 3 over 8 r. Okay, that's done. And then this one is a complete object, the cylinder. So cylinder is pi r square into rho. Okay, volume is pi r square here multiplied by the density rho. Density is not changing now. Okay, guys. So radius of the cylinder, you guys can clearly see this is 4r. Height is 2r, right, guys? So pi r square is gonna be pi, radius is 4r square, height is 2r into rho. All right, guys. So this is gonna be 16r square into 2r. That's gonna be 32r cube. So 32 pi r cube rho. Agreed, guys. And the center of mass. So it's in a cylinder, you know, the center of mass is exactly in the middle, right? So this distance is 2r. So from point O, this is G2, center of mass is directly at a distance r because it's exactly half the height. That's why it's r over here. Okay, is that clear, guys? And then the final object is the one where we remove. Okay, so you have the large cylinder. Okay, and you this is the point O. So you remove the hemisphere. Okay, we remove the hemisphere. And then, so obviously you have to subtract from the 2 pi r cube rho, you subtract the 2 over 3 pi r cube rho. Okay, guys, you subtract. And then the final center of, the final distance is the center of mass y bar. Okay, guys, remember the y bar won't be on the x-axis now. Okay, probably it will, because your x bar won't be 0. Okay, so it will probably be somewhere else. Okay, so maybe this is your somewhere else. Okay, your y bar. Okay, it won't be on this axis. It will probably move a little bit or come to the other side. Okay, anyway, it will probably the center of mass. Okay, because you are removing a mass from here, the center of mass it will probably shift to the side with the higher mass. So your center of mass probably will move somewhere over here. Okay, guys. So this distance y bar is what you are finding. I hope you guys can understand what I'm talking about. Okay, so this is the y bar we are finding. Okay, your center of mass won't be on this axis of on that axis of the cylinder. Okay, because you are removing this mass over here, the center of mass will probably shift to the other side. Okay, so anyway, we are not trying to find x bar. If you're finding x bar is this distance. Okay, so this is the x bar distance. Okay, so the center of mass. So we are not going to be finding that. We are only concerned with the y bar. All right, guys. So this is the sigma mi yi equal total mass into y bar. So minus 2 over 3 pi r. So the reason minus here is because we are removing this guy. Guys, you can change the order. Now over here we have changed the order and done. Okay, so first you can write the cylinder and then subtract the hemisphere or else. So I have first written the subtraction of the hemisphere multiplied by the center of mass plus this is the cylinder multiplied by its center of mass, right guys, equals to, okay, wait. Guys, 32 pi r cube rho minus 2 over 3 pi r cube over rho is 94 over 3 pi r cube rho, right? Yeah, this is 94 over 3, not 22. Okay, so that's why we have written 94 over 3 here. Okay, so 94 over 3 pi r cube rho into y bar. Right, guys? And then you can see the pi and rho cancels out with everyone. Okay, and actually even the r cube cancels out, right? The r cube also cancels out. Okay, so guys, we are remaining with minus 2 over 3 into 3 over 8r plus 32 into r equals 94 over 3. All right, guys. So you can type that in the cal. Minus 2 over 3 into 3 over 8r plus 32r equals 94 over 3 into y bar. All right, guys. So you can subtract, you can get these two guys together and then divide by the 94 over 3. So then you will immediately get the show that 381 over 376 r. Okay, guys. So that's your show that for part A. Okay. So we'll move on to part B. That's another 6 marks. Okay. Part B, they say the hemisphere is filled with water. Okay, so now you have in part A, we removed the hemisphere. So in part B, they are saying they are filling the hemisphere with water. The density of the water is twice the density of the wood. Okay, so the density of the wood, if it is rho, then the density of the water is 2 rho. Okay, so find the vertical distance of the center of mass of the filled bowl from the plane face containing O and the horizontal distance from the axis of symmetry to the center of mass of the filled bowl. Basically, guys, they want you to find in part 1 the new y bar and the new x bar. In each case, give your answer in the form KR, where K is a rational number to be found. So again, that's really easy, right, guys? So all you have to do is now you make another table. Okay, so you make another table in part B, object, mass, center of mass. Okay, so you make another new table and your object is what? Now, since you know the center of mass of the previous, actually we need the y x bar also. So your first object is, first draw this. So your first object is going to be the one where you remove. Okay, This is your first object. Then the second object, guys, the second object is gonna be the bowl that you fill with water. Okay, and then the third object is gonna be the complete one where you have everything together. All right, guys, are you with me? And you need both the X bar and the Y bar. Okay, now it's filled with water. So basically the mass of this object, and you know the center of mass, right? Can you see? You know the center of mass of this object, but the thing is you only know the Y bar. Okay, but the thing is you will also need to find what, guys? You will also need to find the X bar of this object. Okay, because you need to find, you need to know the previous, the one where you remove the hemisphere. You need to know the X bar and Y bar both to fill here, because we need to find the after you fill this with water, we need to find the new X bar and Y bar. Are you guys with me? So to find the new X bar Y bar, we need the previous X bar Y bar of this object. Okay, guys. So we need to refer back to this table and also fill the X bar values here and also do an analysis for the X bar. Shall we do that? So guys, when coming to part B, let's quickly get the X bar. Okay, so how does the X bar work for this object? We'll consider from point O. So from point O, the X bar of the hemisphere, the X bar of the hemisphere, guys, is at a distance R, right? Because you know the center of mass is over here. Okay, and it's at a horizontal distance R from point O. Are you with me? So X bar distance is R. Okay, and then when you consider the cylinder, guys, the center, the X distance, I mean directly the center of mass of the cylinder is on the axis. Are you with me? Center of mass of the cylinder is on the line O. It's on the axis. So therefore, the X distance is 0. Are you guys with me? And then the Y distance is, I mean, the X bar, we'll name it as X bar. So we don't know the X bar. Are you guys with me? So this is really easy. The Y bar distance only, you need to, consider all these vertical distances by considering the hemisphere and the cylinder. But the X distance comes easily. Right, guys? Because the hemisphere, okay, we know that the center of mass is on the axis of symmetry of the hemisphere, and the axis of symmetry of the hemisphere is at a distance R from O, isn't it? Right, guys, are you following me? So this is really important that you understand these small things. And the center of mass of the cylinder is on the axis of its symmetry. So here the cylinder's axis of symmetry, and it passes through O. So definitely the X, I mean the X distance is 0 because it's on the axis. Okay, and then I want to find X bar. So let's do that. Sigma mi xi equal total mass into X bar. So sigma mi xi, that's 2 over 3 pi r cube rho. This is the subtraction. We are removing this into r, then plus 32 pi r cube rho into 0. Okay, into 0 equal 94 over 3 pi r cube rho into X bar. Right, guys? So this entire term is a 0. There's no use of that. Pi r cube rho you can cancel out. So what are we remaining with here? Minus 2 over 3r minus 2 over 3r equal 94 over 3 X bar. The row has cancelled out, right, guys? So how much is it? Can you see we are getting a negative value for r? So X bar is how much? 2 over 94, 1 over 47. 1 over 47 r. Why are we getting a negative value, guys? So it's pretty obvious. Why are we getting negative? Because now the thing is, you know that your object, so let me draw it, try to explain it to you guys. This is your object. Okay, this is the axis of symmetry and this is the ball that you remove. Okay. Okay, and then you measured the distance from this point O. So as I told you guys, when you're removing this mass over here, now I am measuring positive x to this direction, right? So this direction is positive x. So when you're removing this mass over here, what's happening here is the center of mass of the composite body. The center of mass of the composite body is shifting here, guys, because this side is becoming lighter because you are removing. The center of mass of the composite body has shifted to the other side because the center of mass is more towards the heavier side, right? You know that. Center of mass is always biased towards the heavier side. So over here now you have the complete mass over here, but this side you're removing. So that's why it's shifting. That means the center of mass has now shifted somewhere over here. Are you guys with me? So you found the y distance. This was the y bar distance, right? So this is the x bar distance. And the reason you are getting negative is because it is behind O. That's the reason you are getting negative. The reason you are getting negative is because it is behind point O. That's the only reason, okay? Because we consider going front of O, I mean, to the right side of O as positive. So that's, so behind O or left of O is negative. And that's the reason that you are getting a negative x bar answer. Okay, guys? Is that clear? So this is actually quite easy. So we have the x bar answer now. So this is what we require now to go on to this table. Let me move it over here. Okay, so the hemisphere is filled with water. So this hemisphere, I'll do it over here. So this hemisphere in part B, object, mass, center of mass. So what they're saying is this removed hemisphere, whatever they removed, they are now filling it with water. Okay, and the density of the water is twice. Okay, so density of the whatever the ball is made, the water is twice that density. Okay, guys. Okay, so then okay, so this is the object and the mass, we know the mass, right? So 94 over 3 pi r cube rho. Mass is 94 over 3 pi r cube rho. Center of mass, guys, we know both x bar and y bar. X bar was minus 1 over 47 r, y bar was 381 over 376. Guys, for y bar, we don't need, now over here, some of you might be thinking, okay, now y is also below O, right? Do you see? Y is also below O, but we did not consider negative for that. Why is that? Because when it comes to y, we don't have any issues with it. Do we have a part of the object above O and a part of the object below O? If you have that, then you have to consider plus minus. Okay, but here the entire object is completely below O. Can you see? So in that case, you can go everything below O as a positive. There's no need to use negative, right? So you need to only consider plus and minus if part of the object is above O and part of the object is below O. That was the case in our previous question. In this video, when we started, we did one question, right? Where we had a cone and a hemisphere. So the cone was above O and the hemisphere was below O. That's why we had a positive for the cone and a positive distance for the cone and negative distance for the hemisphere. But here, everything is below. So what's the point of using everyone negative? It will all cancel out anyway. Right, guys? So in this case, for y bar, we'll consider the downward direction as positive. Do you understand? But for x bar, we have both sides, right and left. So in that case, for x bar, we will go with the standard notation. Okay? Okay, so this is the object and mass and the center of mass is there. Okay, now let's consider the part that you are filling with water. Okay, so you are filling this hemisphere, the small hemisphere with water. Okay, so when you're filling this with water, this is the point O. So this is the point P. So what's the center of mass? We are measuring the center of mass from point O. Okay, right. So what's the mass? Mass of the thing in the density is 2 rho, but the mass So you know the center of mass is the volume. So it's 2 over 3, right? Half of 4 over 3 pi r cube. Radius is r, right? That's going to be 2 over 3 pi r cube. Into, guys, it should be not rho, but now it should be 2 rho. Can you see the difference? Okay, guys. So then this is the final object. So the with the water. Okay, so can we add everything together? This is 4 over 3 pi r cube rho. Okay, guys. 4 over 3 pi r cube rho. Yes. Center of mass. Let's get the center of mass. So that's easy, right? Center of mass. X distance is directly r. Right, guys? Because you are measuring from O, X distance is directly r. Y distance is 3r away. Okay, X distance I'm considering positive because we are going to the right. Y distance I'm considering we are going down. Everything is below O. Okay, so that's 3r away. Okay, because it's standard hemisphere. Okay, so let's find both X bar and Y bar. So we are supposed to be doing part 1 is for Y bar, part 2 is for X bar. They give you answer in the form KR. K is the rational number. Okay, so part 1, part 1 is for Y bar. Sigma MIYI total mass into Y bar. So let's multiply that, guys. 94 over 3 pi r cube rho into Y distance. Okay, I'm taking the Y distance. And then remember this time you are adding, okay, plus 4 over 3 pi r cube rho into Y distance. Okay, I'm taking the Y distance equal total mass 98 over 3 pi r cube rho into Y bar 1. So you remove pi r cube rho from everyone. Okay, guys, and you can make Y bar 1 the subject. Okay, I'll directly give you the answer. This is something you can get from the cal. So Y bar 1 will be 387 over 392 times R. Okay, guys, that's Y bar 1. And then part 2, sigma MIXI equal total mass into X bar. So that's going to be mass 94 over 3 pi r cube rho into X distance is minus 1 over 47 r. Okay. And then you're adding with the other object 4 over 3 pi r cube rho into r. Remember, I'm now taking the X distances, the Y, because I'm finding X bar equal total mass 98 over 3 pi r cube rho into X bar 1. So once again, pi r cube, I have not written the row here, right? 94 over 3 pi r cube rho. Pi r cube rho cancels, pi r cube rho. All right, guys, and then you can get the X bar 1 answer. That's going to be R over 49 or 1 over 49 times R. Okay, so you can get that. That part is easy. So, guys, that's the answer for part B, Roman number 1 and 2. Okay, guys, so this is the full center of mass question. So now I believe you guys, if you paid attention to this properly, that you should find this lesson. It should be quite understandable and manageable, right? Okay, so I hope you understood everything that we have done in this lesson so far.